everyone, and welcome to the Learning Space Tuition's Statistics Workshop. This is part 1 of our Statistics Workshop. And in this part of the workshop, we will be dealing with two aspects of statistics, that is our measures of spread and our measures of central tendency. Now, a measure of spread describes the variability between your data points. So for example, how much does each data point differ from the other on average? An example of a measure of spread, if you have two classes, class A and class B, and both classes have an average of 60% on their maths test. In class A, you may have a top value of 60 and a low value of 20, whereas in class B, you could have a top mark of 75% and a lower mark of 50%. So in both of those classes, you have the same mean, the same middle average value, but the spread of the data differs in that you have a different higher and lower value. Our measures of spread are our range, our interquartile range, our semi-interquartile range, our standard deviation, and our variance. The range just being the difference between our topmost value, the maximum value in the set, and our lowermost value, the minimum value in the set. The interquartile range being the difference between our upper quartile and our lower quartiles, the semi-interquartile range being half our interquartile range, the standard deviation being how much the data differs from the mean or deviates from the mean on average, and the variance just being the square of the standard deviation. We will be dealing with all of these aspects in more detail later on in this workshop. Our measures of central tendency are basically describing what is happening in the middle of this data set. So central, think middle. And our measures of central tendency are going to be the mean, the median, and the mode. You know that the mean is going to be the average value in our data set. And that's like how we would calculate our average mark for maths out of all of our individual little marks that we've gotten over the year. The median is going to be the middlemost value in our data set. So that's the value above which half of our data values lie, and below which another half of our data values lie. And our mode is going to be the data value that appears the most in our data set. So for example, if we have two phones, if we have Samsungs and Apple phones in a school, if we want to figure out which phone is being used the most, we'd find the modal phone, or the modal data point of the phones. Okay, so let's do some practical examples with medians, quartiles, the interquartile range, and the semi-interquartile range. You recall that the median was described as the middle position or the midmost position in our data set. So when we have a data set like this with 13 values, with 12 values in this data set, we know that we have an even number of data points. Therefore, the median, the midmost point, is going to be between two values. So let's count from both sides. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is dividing our 12 data points in half. Our median is going to lie in between our 6th and our 7th data point. That is quartile 2. Therefore, if we're trying to calculate the median position, we're going to say 8, which is our 6th value, plus 9 divided by 2, because it's between those 2 points. That is going to give us a median of 8.5. To find our quartiles, now our quartiles are dividing our data set into their quarters, let's say. So you know that to find a quarter, you simply halve a half. So to get our lower quartile, if we know that half of this data set is at Q2, the lower quartile is going to be at half of that. And let's pick a different color to depict this. So this is the lower half of our data set. If we're halving that, we're going to count 1, 2, 3 on one side, 1, 2, 3 on another. The lower quartile, the midpoint of this lower half, is between 6 and 7. To calculate the value of that, we're going to say 6 plus 7 divided by 2, and that's just going to give us 6.5. We're going to calculate our upper quartile in the same way, using the upper half of our data set. So we know that between 9 and 19, with these 6 values, we're going to have to divide it into half to get our upper quartile, Q3. And so Q3 is going to be between 15 and 17. To calculate that, we're going to say 15 plus 17 divided by 2, and that is going to give us a value of 16. Now, what this means is that 25% of the data lies below quartile 1, 25% lies between Q1 and Q2, 25% lies between Q2 and Q3, and between Q3 and our maximum value, we also have another 25% of our data. If we're trying to find the interquartile range of this data, interquartile range is just the difference between the value of our upper quartile and the value of our lower quartile. So that is just 16 minus 6.5. And that will give you a value of 9.5. Our semi-interquartile range is just half of our interquartile range. Think semi is half. So we are going to divide that 9.5 by 2 to get an answer of 4.75. Now that you're comfortable with calculating the values and finding the positions of these measures, I'd like you to try an example of this, after which we'll work through it together. Great. Now that you've had an opportunity to take a look at this example, let's work through it together. Now, before we had an even number of data values. In this example, we have an odd number of data values. And so, if we're going to find the midmost value in the set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points, we're going to count 5 units from point 1 to point 5 and 5 units from this endpoint, and we'll find that the midpoint of this data set is at 8. This 8, that is. Therefore, you have 1, 2, 3, 4, 5 data points below it, 1, 2, 3, 4, 5 data points above it. It is perfectly in the center. This is our median value, or our median position. And in this case, our median position is going to be the value 8. We don't have to do any other calculation. We'll simply accept that to be our median value. Now let's find our upper and lower quartiles. Remember, the quartiles describe the median between our minimum value and our median value, and our median value and our max value. So to find the lower quartile in this example, we would just say 1, 2 units from this side, 1, 2 units from that side, where we have a total of 5 units. The third data value is going to give us our lower quartile. And the value of that we'll just read off as 6. Our upper quartile will find the midpoint of this interval, and that's just going to be at 15, where we count 1, 2 units to the left and 2 units to the right of that. And the value of that is going to be 15. Let's calculate our interquartile range in this example. The interquartile range is just going to be the difference between the upper and the lower quartiles. That is 15 minus 6. And that is going to give us a value of 8 for our interquartile range. The semi-interquartile range is half of that, and that's just going to be equal to 4.